That wasn't the short question.
Yes, that's okay. Thanks. Okay, we're going to wrap up the day with 3 presentations from our sponsors. We're so grateful to them. Without them, we wouldn't be able to put this on, and so we always give them a chance to stand up and some of them make presentations throughout the workshop, but particularly it gives them the opportunity to plug their organization, and we're happy for them to do that because they are so kind in sponsoring the workshop. So first off is Joel. Joel, when you're getting done, we have your slides that you wanted to show in those books.
Okay.
And so once you're finished with your presentation here, Melissa will pop up those slides, and then we'll give away the book.
Okay. So I guess I get this button, right? So I like to show off what everybody's done during the year, but I don't even get the whole year here. I only get 4 months. So this has been a busy year for launches. I think a lot of the people in here deserve some credit for something on here. So we'll start with CalifaSat. That's the UAE's first satellite. And we've got a rep from there. And then, of course, Solar Probe. That's a classic flight software workshop. Bepe Colombo. I'd love to know more than Murtis, but I know we're at least on Murtis, so that gives me a... You're not? Oh, okay. Well, I had trouble finding that. It's really hard to dig this stuff out unless people tell you. Thank you. ISAT-2. Ironically, I helped do the BSP for the RAD 750 in that during an ice storm that froze Huntsville down for 2 weeks. So it's really funny that's finally launched. That's taken 7 years from BSP development. But Cropus is actually, for a small mission no one's ever heard of, is pretty neat. They're testing a new life support system, and they're supposed to grow tomatoes in space, which just sounds amazingly cool to watch. So that looks like one to watch. There was another instance of the Electra radio that's on Mars now on InSight, and I didn't bother to put that up there. Some of this is an updated version of what we presented last year. We are now looking at trying to branch 5 this year. As I've explained to lots of people, we think the next major release is what I call a 10-year release, with the ESA qualification activities being the first production-ready release with SMP. We think it's going to be one people are going to use for a long time, like ESA has used 4.8 and NASA has used 4.10. So we're just going to go through some things that you might know or not know. There's a trend now to go away from 3-digit version numbers to 2-digit version numbers because nobody ever changes the first digit. In truth, we probably should have already changed it 3 or 4 times. And 4.5 was a joke anyway because I said we were halfway done implementing all the POSIX I thought we could support. So there is no like 4.1, 4.2, or 4.3, or 4.4. So there were some jokes in there along the way. The tool names are still, tools are versioned. You can now build 4 languages right from the RTEMS source builder. Some of the really big stuff that is up here that'll matter is 64-bit time T. That's really important because 2038 is not that far away. I mean, some of these missions will last that long even though you may not use POSIX time. I know there are building controllers with RTEMS, and putting a building controller in now at this point, 20 years, is not a long lifespan. So one of the other things, which we've got C11, threading and synchronization, that's in support of the SMP, and C++, we've got the 11 and newer because of that. One of the things that is really neat is we're now constructed via sequence constructors, which is an idea we took from FreeBSD. That is the last of the ideas I have for making executables smaller. The big one here, though, that I'm not going to harp on it. Python 2 has been officially deprecated by the Python Foundation, and you're going to start seeing problems on your host systems with every Python application you've ever had. We recently have seen a couple of distributions that don't even have the program user bin Python. And a lot of our native stuff is in Python, so we hit a brick wall a few months ago and had to address that. There's the Python PEP, and you should read it because you're going to end up dealing with it. I know some of the Marshall people said they ended up doing that when they installed Ubuntu 18. They hit that brick wall right as we were trying to fix it. We have updated a lot of things, JFFS2. Some of the really cool things, since we're using the FreeBSD TCP/IP stack and USB stack, not everybody knows it. Netflix is a big supporter of the FreeBSD stack and FreeBSD. They use their entire infrastructure on FreeBSD, so we get all of the drivers, but we actually now have 10 gigabit Ethernet drivers, which is pretty amazing. We have and reorganized, and so everything you ever knew about the confusing header files and layout in RTEMS is now, they're all completely flat in a one directory system. The BSP tree has been reworked. A lot of the things we thought were misnamed have been fixed. The build speed up, the build system is a lot faster now. There are a lot more test executables, and over in the examples, there are a lot more examples. So we're trying. One of the nice things is the SMP is now production worthy. It has a lot of things that if you look up the implementation, you'll find academic research papers with proofs and solid theory behind them. One of the things I've really has made me realize how much the RTEMS community has grown is RISC-V went from not present in 4.11 to maybe present 18 months ago to now running SMP systems. So it's gone from not present to SMP in about a year and a half. There's lots of stuff that's been implemented, improved. A lot of these are to make SMP systems analyzable, predictable, and more efficient. We've published papers on on the update of the TCP/IP stack. What we've done is implemented the FreeBSD device driver kernel interface and can bring over almost completely unmodified all of the device drivers and protocols for the FreeBSD TCP/IP stack, IPv4, IPv6, IPsec, device drivers. We also can bring over the USB stack. You now configure the network stack just like if you were reading this FreeBSD system administration guide. So it's much easier to do than it was. It's also much faster. It takes advantage of onboard checksumming and onboard DMA and other accelerations that the newer NICs have. There was a lot of things added, a lot of things removed. The MIPS, for those of you who worked with it, no one will miss the Mongoose 5 being gone finally. One of the things that's been really neat is that, and I had a slide on this last year, but there's a new document. We've converted it all to Sphinx, which is what the kernel is, and a couple of other projects have mentioned producing Sphinx. One of the things that's new is this RTEMS POSIX compliance guide, which if you look down the left-hand side somewhere, there's probably a pointer on here. This is the various sets of POSIX standards, POSIX profiles, C language standards, FACE avionics profiles that are targeting various aviation, like level A, level B type products, and then the SCA is a software-defined radio standard. We actually document which subset of POSIX we have versus each of those standards, so you can tell how conformant and compliant or whatever we are to each of those profiles. As a general rule, we have approximately 1,100 of the 1,300 POSIX routines, so we're just missing the multi-process stuff. So mostly everything you expect to be there is there. When I was putting this together, we were just coming off of the Google Summer Code, and I never really brag about the students, but I wanted to. We had 4 really good students this year. We had one who brought over the FreeBSD SDIO driver. We already had the SDHC. He got a published paper. He had a lot of graphs on benchmarking, but the paper was actually, he was benchmarking different file system performance on the same, on a RAM disk. So you could know picking the file system had impact. So was the DOS file system, the RTEMS file system, or the JFFS2 the fastest on a particular media, which is a different way to look at the file system because the block device was RAM, so it was all the same. So he added another way to get SD cards read and write into RTEMS, and he got a published paper out of it, which is good. This is a student who did a little bit of a different project for us. She did 2 documentation conversion scripts. One was to we use track as for ticket tracking, and we don't like the way it generates release notes. So she wrote something to pull the data out of track and generate a really nice release notes from into REST. The other one is the C library we use, NewLib, which is the same as SIGWIN, has approximately 400 libc, libm, and POSIX methods documented, and they're in their own thing like Doxygen in the source. So she wrote a utility to take those out, chew them out, and spit REST. So we picked up the potential for 400 more POSIX methods and libc methods documented, which before we had been relying on shipping their manual. So that's a big deal. There's almost always a student who works on the coverage reporting. I had been wanting to break it up so you got coverage reporting per functional area because it's not up here. But if you look, the FAT files, there it is. The DOS file system in RTEMS terms has really poor coverage. And he wasn't running all the tests. He was just, so the coverage is actually better than that because if you look, there's like 0% covered because it takes forever to run the tests to analyze them. We finally had somebody who bid off on doing a true non-legacy 64-bit PC port that didn't require any legacy peripherals. So we had a student do this, and so he has a basic functional BSP. So now it's just got to have devices added to it and smooth out the building a boot executable because it's a little strange now because of the EFI stuff. Google Code-In is Google GSOC, Google Summer Code, is for college students, so you essentially get a virtual summer intern. We've had about 100 of the students over the past 15 years like that. Google Code-In is completely different. It's a high school program where you give small tasks to students and they sign up. Instead of being 200 organizations and 1,300 college students in Google Summer Code, this year, as of last week, you can see the number here. It was only 27 free software projects participated, 2,600 students from 7,400 countries, and 11,500 tasks completed. A task takes 4 to 8 hours. To give you an idea of some of the stuff we've done, we've had them writing benchmarks for POSIX cases. One of my favorites here is actually, I didn't have time to add it because it happened so late. Last year, Scott Zimmerick gave us an outline for an RTEMS software engineering handbook that would look like what he expected from the NASA quality standard, and he gave us URLs in the wiki of where to get the content from. I think we're one wiki page away from completing the conversion based on high school students doing them one wiki page at a time to rest. So we've had a lot of really good, solid work done by high school students, but you have to micro-plan things down to, I mean, I would give like that whole task to somebody at work. I'd give them one example and go away for a few weeks and expect to have it done. But here we had to break it into like 70 tasks. So it's a different style of management, but you can get real work done by high school students. It's pretty challenging. And one of the students has actually been watching this week on the Flight Software Workshop, so he's been enjoying it. We also have been building up an ecosystem, and most of this is actually here at this point. The source builder, probably everybody's used. You can use build tools and add-on libraries. The RTEMS tester, you can automate testing on simulators and real hardware. The loader is part of the dynamic loader, which Alan has been instrumental in making sure happened. We have a trace engine and a trace linker. One of the things there is somebody mentioned generating the marshalling or serialization code based on the dwarf information. You can actually also generate trace linking wrappers for the same way. And then the coverage testing and reporting. And all of this is built up, so you get a command line interface. We don't have much in the way of GUIs, but the users use it, the developers internally use it, and then it's supposed to feed into the continuous integration testing, which is still not completely set up because that's done by volunteers. So after this release, we're going to the plan is to convert the main tree to the WAF build system. All the other RTEMS support modules and Git repos have been converted. We would really like some stuff in the ecosystem done, like there's some roadmap for the coverage analysis reporting that's been done, the support for the Eclipse common trace format and target communications framework. Those would basically let Eclipse work out of the box with all the fancy thing like timeline and tracing and all of that. And I'll put this down just for Alan's benefit that the Microblaze port is still on the wish list. And it probably has been there forever, right? That's one bullet I never have to change, right? You save me the trouble of ever actually deleting it. Remind everybody that the hosting is actually at Oregon State with machines that have been bought by either donations from doing student programs or by OER. It's all shared by the community. The administration has been completely volunteer. It's an underappreciated shared resource. So, and the sysadmin has never actually done any paid RTEMS work. So it's when I say donations, I'll get back to that in just a second. We are in the middle of doing a relicensing effort. We have permission letters from almost all of the key people that are needed to make the announcement. OER, Embedded Brains, Jerry Geisler, and a few others who cover most of the core code anyway. The intent here is to go from the current RTEMS license to a simple 2-paragraph BSD. It has no practical impact on the way anybody uses RTEMS or passes things along. It just makes it easier to explain to a lawyer. That's all it really does. We pretty much got everybody to agree. There's just a few people we want letters from, permission letters from, before we ask the broader community. If you know you got contributions, you can ask. We'll give you the template for a letter. This has been done pretty much publicly too. There's a ticket tracking this. We're just going to start hammering on the permission letters once we get the core, about 10 contributors to get letters from them. This is pretty amazing. I actually had to insert 2 slides this week. Last year, Scott Zemmerick gave us, like I said, an outline of how to start getting a software engineering guide. We're pretty much ready to the first draft of that to start trying to improve it. And hopefully, over what I'll talk about in the next couple slides, we will end up with a fully testable, traceable requirement set and support for being able to go through more qualifications. There is a qualification mailing list at RTEMS, and what we do is we anticipate 5 is going to be used for flights for SMP. This is an area where the core developers do not have expertise in flight qualification for NASA and ESA. We need help from the community to know what to do. We're happy to do whatever it takes as long as we can keep it in the open source shared model. And now I'm thrilled to finally be able to, that this is finally happening. ESA is doing their 4th qualification effort for RTEMS. They've done 3 previous, but this one, the intent is that the work will be done in the public, the work products, and what I like to call technical data will come back to the RTEMS project, so that hopefully the technical data can be used to generate qualification packages. They're intending to do what it says on the goal is a level C, which B is a little different on the coverage, which probably will still do a level B type coverage, but they probably won't do the independent software verification. You should recognize a few of the people. Edisoft supported the 4.8 that ESA has used for a long time. Embedded Brains has a number of core developers. Liro here is a formal methods analysis place. And Jenna Optronic, I am pretty sure Jenna has been here at the Flight Software Workshop before to talk about their tracker. They're also involved in this. They're an RTEMS user. So the intent here is like I said, is that going to open source as much as they can, feed it all back into the community so that basically what you get is what the FAA calls a reusable software component that's more adept and easier to take from the open source community than bring through verification. So the last thing here is really hard because we want to do this so we can still stay within the guidelines of an open source project and not crush things. Because sometimes this kind of process can be quite heavy. But we want it to be open. We want NASA involved. We want everybody involved to tell us what would make it easier to do it. One thing that should be clear is that ESA is focused on an SMP configuration for a Leon 3, Leon 4. They don't have exactly the scope, but if 4.8 that was qualified, they qualified with any guide. It was a very small set of the classic API, but since it's SMP now, and a lot of the infrastructure has been discussed, requires more functionality. Like you guys experimented with OpenMP and MPI, and if those things come along as requirements, then you will need more infrastructure than you had in 4.8. So this set of software to be done is going to have to be defined, and it probably will not 100% line up with what NASA uses. So everybody wants input, but this is just hopefully a framework at which different configurations can be qualified. We would like to get all of the stuff back. This last one, these last bullets really sound a lot like the FAA's reusable software component. What you get is a kit of all the data and the questions that you have to fill out in the process you follow when you do a validation effort on your own target hardware for your own system. So that's where we're headed, and we would be the first open source project to be doing this. So that's where the challenge is, but we want to be completely open in the process. And on a similar vein, but not as formal flight verification, I mean, you can see the banners out there. We've been working with DOS for a couple of years, mainly to run RTEMS in an ARINC 653 partition, which is not the first time this has been done, but it's the first time that RTEMS has been probably integrated as well as it has. RTEMS is supported on their primary targets of ARM, PowerPC, and x86, and the focus is meeting what's called FACE safety-based configuration for the FACE Technical Standard 2.1, and we're going through formal verification on that now. We plan to do a FACE Technical Standard 3.0 verification once the conformance program is officially in place. The conformance test suite has not been released for 3.0 yet. One of the things we think that, based on some changes in 3.0, that the POSIX subset here that meets this profile is only about 250 calls. We think that based on the changes, we can actually meet what's called the general purpose profile, which has about 800 calls in it. So this is a very robust environment. It also has the classic API and all the other threading and tasking things you expect. And this is, Gary didn't put this slide up, but the idea here is you can configure each partition to be the executable environment you need, and then the cool thing about the FACE operating system profile is you actually get access to shared memory to communicate with other partitions. You get access to sockets. You get access to ARINC 653 queuing ports and sampling ports from the POSIX environment. So it's fairly easy to get out of the partition. It's a pretty clean integration. It's a very clean integration with between the environments. So basically, I forgot to ask a question. Does anybody know the significance of December 31st, 1988? If you've ever run the ticker executable, that's the date that the ticker executable, the sample and test program for RTEMS sets. This is now the 30th year of the RTEMS project. So that was, so it's been open source from the very beginning, never an academic project, and it's only stayed around this long because people have been used it, contributed, funded improvements, projects like MMS. I mean, ST5 was our first mission with NASA, and that's led to a lot of others. I think Proba 4 was the first ESA mission. Everybody, there's always a first mission, and then other people can adopt it. It needs to be de-risked. But we've had a lot of launches. SWRI has had a lot of projects that use it. We've now been with the Sun and Mercury missions. As soon as those get to the right spot, we have been everywhere from the Sun to Jupiter. So we have a pretty long heritage and a lot of stuff on Earth and space, a number of science discoveries, but those are all thanks to you guys and the experimental physicists who use it. And just please help support us, contribute, use it, complain, give ideas, whatever it takes. So that's where, because it wouldn't exist if you didn't use it. I'm happy for questions. I think that's it. So you guys know how to get me anyway. Oh. That was
Sleeping.
I should have planted one. I should have planted a question. I feel.
Yeah. All right. We're good.
Well, this is better than the year somebody asked me what a thread was. That kind of shut everybody down. Did you have one back?
Oh.
No, for some reason nobody actively worked. It's there. It was working in the early part. There are a couple of tickets outstanding. Ironically, everybody worked on Spark, PowerPC, and ARM, and then they worked on the RISC-V before anybody actually cared about an x86. It's close. I think the main ticket at this point is there's a synchronization spot in the context switch to make sure a thread is completely off of one core before it's potentially put on another. And basically, there's a synchronization assembly statement that has to be implemented. And I think that's it, other than testing. But nobody's volunteered to take the time. It was working, because that's where it was first implemented. It's just got to be caught up.
Okay. Let's hit your slide, and then we'll drop to the books.
This is, for those of you who've been around a number of years at the Flight Software Workshop, and remember Alan Unell, every year Alan Unell put a plug in for this book. And there's a number of us here who've tried to hunt it down on Amazon while he was talking. And believe it or not, this book is really hard to find. It took me, I think, 3 years of him plugging it before I finally managed to buy a copy sitting out in the Beckman Institute. So I managed to get one copy off Amazon this year. So somebody's getting lucky enough to get Alan Unell's favorite book. Oh, no. Vivek, Koshi, you want to try?
Okay, yeah, Vivek.
I'm gonna
Yeah.
the cool thing about this book is he's a social scientist, and he looks at why things break. Like, why do we still have boat shipping accidents? Why don't we know that chemical plants are eventually going to break and leak? Why don't we know these things and plan for them? And a lot of the things are human errors in the way they're designed. Like 3 Mile Island, he does a lot on 3 Mile Island, and it turned out that the indicators that really mattered were on opposite sides of a huge analog panel. One was covered by a tag. The alarm bells were going off, and the plant manager was yelling at them at the time. So, I mean, how could you have expected anybody to have done anything right under those circumstances? But a lot of these things are, from a social standpoint, it gives you a different perspective that we really should know things fail, and we should plan for them to fail so we could plan for how to clean them up better. And then real accidents malicious acts wouldn't be as bad. So it's a great book.
All right, and we have one more copy of the rocket science book, I believe.
Now, so yeah, we've talked about Dr. Rogers. So now we got one more book.
Okay, so we'll draw for that one.
Here you go, Alan. You're lucky.
Oh, he can't draw.
Well, mine might be in
He'd probably draw his own name.
It's not Alan. Veer Kumar Mota? I'm either butchering it or they're not here.
Yeah, let's say. Okay, so we have Veer Kumar Mota. Okay, we'll try another one.
I can do this one. Addison Fowler? All right.
Okay.
That should be a long A, right? It's Failer?
Okay, good. Thank you. All right, great. Well, I think we have, I believe it's MathWorks